the dependency inversion principle is very simple, and it states that high-level parts of the system should not depend on low-level parts of the system directly, that instead they should depend on some kind of abstraction. So this might once again seem very cryptic. I mean, what does it mean to have high-level and low-level parts of the system? Well, we're going to take a look at a scenario right now. So what I'm going to do is I'm going to model a genealogy relationship between different people, and we're kind of imagining a system where you perform queries on a genealogy database. So first of all, we may as well define certain relationships. A relationship between two people, like for example, you can be a parent, you can be a child. That's going to be an enum, by the way, not a class. So enum. You can be a parent, you can be a child, you can be something else, like a sibling, for example. So these are relationships that you can have between people, and then we can define person. And here I'll do a very simple definition. I'm just going to have the name of the person, although strictly speaking, in a genealogy application, you would have other information as well. Like, for example, you might have the date of birth, for example. So these sorts of things. Now I'm going to just ignore everything except for the name, just for the sake of simplicity. So now that we have this kind of setup, we may as well define the low level, and I'm going to write it here, low level parts of the system by defining relationships between different people. And I'm going to put them in a class called relationships, like so. And here we're just going to have a flat list of relations between different people. So I'll have a private list, and I'll use the C#7 tuples here. So I'll have the person from which the relationship stems, the relationship itself, and the person to which the relationship applies. So person, relationship, person as a value tuple. Let's go relations, and I'm just going to initialize it with a new list. Let's try and do it this way. So person, relationship, and person again. There we go. So this is a set of relationships that we have at a low level, and what we can do then on the low level is we can define some sort of API for actually adding a parent and child relationship. So I'm going to do it very crudely. I'll have add parent and child, and here I will have the person parent and the person child, and I'll just duplicate the data. Not something that you do in a typical database, but something that is very popular in today's design when you just duplicate data for the purposes of speed of access. So I'm going to say relations.add, and then I'll add parent with the relationship of parent. That should be relationship.parent to the child, and then of course I'll add the reverse relationship just for the fun of it. So here you would have child relationship dot child, and then the parent. This is completely spurious. I'm just adding it to show that you can store things in this kind of denormalized way. Okay, so this is our low-level API, and the question is, well, how do we actually perform research on it if we want to find out all the children of a particular person? Well, let's actually do this. Let's make a class called research. Now in the main method, I'm going to set up a scenario. So I'm going to have a bunch of people. I'll have the parent as a new person with the name John, for example, and then I'll have children. So we'll have child 1 like so, and child 2 here as well, child 2, and I'll call them Chris and Mary. There we go. So John has 2 children, and we can define the low-level relationships module to kind of encompass this information. So we present this information. We say var relationships equals new relationships, like so, and then I can say relationships dot add parent and child. So parent child 1, and then duplicate and child 2. There we go. So we've set up the scenario, and now we actually want to perform the research. So we want to take the low-level module, and we want to somehow access it in a high-level research module that we have here. So one of the ways, not the best way, is to simply allow the high-level module, the research module, access to some of the internals of the low-level module by giving it the list of relations. So you can do something like the following. If we make a constructor for research, we can have a constructor which actually takes relationships as the argument. We take the relationships as the argument, we pass in relationships in here. So we say new research with relationships. And then of course, what you want to do is you want to access all of the relationship information. So how do you do it? Well, one of the ways is you simply expose this private field as a public property, and that's pretty much it. So in this case, what we can do is we can write something like public list of person relationship person. We expose this list called relations with a capital R as relations, like so. Okay, so we've just made a property getter for this field. And what we can now do is we can perform some sort of research by accessing this low-level interface. So I can say var relations equals relationships.relations, like so. I'm accessing that property that we just made. And then I can go ahead and look for all the children of John. So I can say var r in relations dot where, and I can start filtering. So I can say, well, I need the name to be John. So if we take x as the argument, I want x dot item 1 dot name to be equal to John, and I want the relationship type, so x dot item 2, I want the relationship type to be relationship dot parent. So I want somebody for whom John is a parent. So then I can do a loop, and I can actually write line. I can write line here that John has a child called r.item3.name. Okay, so this is a workable scenario. It will actually work if I sort of compile and execute this, but there is a bit of a problem here that we need those references to value tuple, of course, since I'm using the C#7 variety and we're still in Visual Studio 2017. I use value tuple to get my package in here. There we go. All right, let's get those value tuples in, and now hopefully if I execute this, I get my result. So John has a child called Chris and another child called Mary. There we go. Now the problem with this scenario, and the reason why the dependency inversion principle exists, is that we're accessing a very low level part of the relationships class. We're accessing its data store, and we're accessing it through a specifically designed property which exposes the private thing as public. And what this means in practice is that relationships cannot change its mind about how to store the relationships. So the relationships class cannot say, oh, this is a bad way, I'm using tuples, I'm depending on this value type, I'm going to start using a dictionary and I'm going to remove this duplication as well, or something to that effect. So it is a very bad idea, because then the relationships class can no longer really change in terms of the way it stores data. So a better way, which would allow relationships to change, is to provide a form of abstraction by simply defining an interface for how the relationships class actually allows you to access certain high-level data. So for example, I can define an interface called iRelationshipBrowser. So this concept will actually give us particular information, like suppose I want to be able to find the children of a particular person. So what I can do is I can put here a member which returns an IEnumerable of person, and it's going to be called find all children of, and you specify the name of the person whose children you actually want to find. And then of course what I can do, instead of instead of doing this, which is horrible, I'm going to comment out this whole thing, is, well, actually not just the constructor, but let's comment out the entire body as well, is I'm going to actually implement the interface that we've just made, which finds all the children of a particular person. I'm going to implement this in our low-level construct. So here I'm going to say iRelationshipBrowser, like so. I'm going to implement the missing members, and here all I have to do is I have to basically replicate the kind of call that I'm doing here, except it's obviously going to be slightly different. So if I just copy this over, let me just paste this in here, and I'll uncomment this as well. So what we're trying to do is we're trying to search everyone with the particular name. So instead of John, we put the argument, which is name, like so, and then we simply yield return the actual value, which in this case is r, and we can actually simplify this because none of this is required. Well, it's not r, it's r.item2. That's the child. Item 3 rather, that's the child that we want to return. So I'm going to simplify this, convert this into a basic link, and there we go. So we now have a low-level module, but instead of depending on this low-level module, we depend on an abstraction, which is the iRelationship browser. So what we can do in our research module, which is the high-level module, is we can build another constructor, but this time around, we don't depend on relationships. Instead, we depend on this iRelationship browser interface called browser. And here, if I want to find all the children of John, all I have to do is say for each var p in browser dot find all children of John, and I can once again write line John has a child called, and then just say p.name. Also looks better in terms of the API, and of course if I execute this I get exactly the same result, but I get it without the dependency on low-level implementation details. So now what happens is relationships can actually go ahead and change the way that it stores the relationships. It can change the underlying data structure because it's never exposed to the high-level modules which are actually consuming it.